This lesson is going to be looking at multiplying and dividing numbers that are written in scientific notation. In order to multiply numbers in scientific notation, there are 3 steps. The first step is to multiply your decimals together. The second step is to multiply your powers of 10 together. And then the last step is to adjust the exponent if the number is not written in scientific notation. Let's take a look at an example. So we have 2 1/10 times 10 to the 6th power multiplied by 3 4/10 times 10 to the 7th power. So I want to multiply the decimals together. So I'm multiplying 2 1/10 times 3 4/10. Now remember, when you multiply decimals, you multiply first like the decimals aren't there. So 4 times 1 is 4. 4 times 2 is 8. Then I want to go into the 3, so I'm going to use a 0 as a placeholder. 3 times 1 is 3, and 3 times 2 is 6. I can add them together. 4 plus 0 is 4. 8 plus 3 is 11. Carry the 1. And then 6 plus 1 is 7. Now, I don't just drop my decimal down. I have to look at how many numbers I have behind my decimal. I have 1 here, and I have 1 here. That's 2 in my problem, so I have to go in from the back, 2 spaces in. So I'm going in 1, 2. So 2 1/10 times 3 4/10 is 7 14/100. Then I have to multiply the power of tens. So I have 10 to the 6th power times 10 to the 7th power. So if you remember from the multiplication property of exponents, I keep my base the same, so the base stays 10. And then I take my exponents, and because we're multiplying, we add them together. So 6 plus 7, which gives me 10 to the 13th power. So then I want to put my numbers together. So I'd have 7 14/100 times 10 to the 13th power. The last step is to make sure your number is in scientific notation. The most important part to look for here is that you're looking at this number, your decimal. Remember, in order to be in scientific notation, a decimal has to be between 1 and 10. And 7 14/100 is approximately 7, and 7 is between 1 and 10, so we are good here. So our final answer to that problem is 7 14/100 times 10 to the 13th power. Okay, let's take a look at another example. So this time we're going to be looking at 2 3/10 times 10 to the 5th power multiplied by 5 5/10 times 10 to the 8th power. The first thing we need to do is multiply our decimals. So our decimals are 2 3/10 times 5 5/10. So 5 times 3 is 15, carry the 1. 5 times 2 is 10, plus 1 gives me 11. I put my 0 as my placeholder, and then we move into the second 5. 5 times 3 is 15, the 1 is carried. 5 times 2 is 10, plus 1 is 11. So now I can add them together. 5 and 0 is 5, 1 and 5 is 6, 1 and 1 is 2, and then the 1. So starting from the back, I need to move my decimal in twice because I have 2 numbers in my problem, the 3 and the 5, that are behind the decimal. So I go in once, twice. So I have 12 65/100. And then if I do my exponents, I multiply those together. Remember, I have 10 to the 5th power times 10 to the 8th power. When you're multiplying exponents, remember your base stays the same, so it stays 10, but I take my exponent and I add them together. So I have 10 to the 13th power. So I have 12 65/100 times 10 to the 13th power. Now we have to ask ourselves, is that number written in scientific notation? Your answer to that should be no, because the decimal is not between 1 and 10. So in order to make it written in scientific notation, what you could do is you could look at it and say, okay, I can rewrite this in standard form. So that means I have the original number 12 65/100, but I take my decimal, and because it's a big number, it's positive, I have to move my decimal 13 times to the right. So I'm going 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. And then all of those empty spaces are going to be filled in with zeros. And then I have my commas after every 3 from the back. Okay, Now, if I was going to rewrite this number in scientific notation, I know that my number has to be between 1 and 2, or 1 and 10. 12 is not. So I want to move my decimal, and it's right now, right here, and I want to move it so it's between 1 and 10. 12 is not, so I have to go one more space over. 1.265 is between 1 and 10. So my decimal now becomes 1 and 265 thousandths times 10, but because we moved it that one extra space, my decimal instead of 13 is going to become 14. So my final answer is 1 and 265 thousandths times 10 to the 14th power. Now, instead of necessarily writing it all in standard form, you could recognize from this point up here that you need to be this number, the decimal, in between 1 and 10. And you could have recognized that you had to go one more spot, which would have caused the 13 here to become more, which would become a 14. If you can recognize that, then you do not necessarily have to rewrite the number in standard form and then move the decimal all the way back over to find the number that's between 1 and 10 to be able to figure out what your decimal and what your exponent should be. Let's take a look at division. Division is very similar to multiplication, except that instead of multiplying, you are dividing. So let's take a look at this. If we have 6 times 10 to the 5th power over 2 times 10 to the 3rd power, I want to divide my decimals. So 6 divided by 2 gives me 3. I still have my multiplication symbol, and then I have my exponents. My power is a 10. 10 to the 5th power divided by 10 to the 3rd power. When you're dividing exponents, you have your power stay the same, your base is the same, but then you take your exponents, the power, and you subtract them. So I'd be left with 10 to the 5 minus 3 power, which is 2. So it's times 10 squared. So looking at this, we want to see, is this number in scientific notation? And again, how to check that is you have to check your decimal number. That decimal, again, needs to be between 1 and 10. If it is, your number should be written in scientific notation. 3 is between 1 and 10, so that is written in scientific notation. Let's take a look at one more example. So we have 2 times 10 to the 7th power divided by 8 times 10 to the 3rd power. The first thing I have to do is divide my decimals. So if I'm dividing my decimals, be very, very careful here with how you divide. When you divide, if you're going to do the long division, the number that comes first in the problem goes in. The way I remember it is in and out, like the restaurant. So the number that goes first is the number that goes inside the division sign. So that is not equal to 4, because if we're doing the division, my 8's on the outside, 8 doesn't go into 2, so that's a 0 up top. Then I have to add a decimal and a 0. 8 goes into 20 twice, because 8 times 2 is 16. I subtract 20 minus 16 and I get 4. I'm still not done because I have a remainder, so I have to add another 0, bring it down, and then I'm looking at 8 going into 40. 8 goes into 40 evenly 5 times, because 8 times 5 is 40, so then there's nothing left. So my decimal part of my answer, right, because I have my decimal I had to add, is 25 hundredths. And it's going to be multiplied by 10 to something. And if I'm dividing, then 10 to the 7th power divided by 10 to the 3rd power. Remember, we keep our base the same, so it stays 10. And then my exponents we subtract. So 7 minus 3 gives me 10 to the 4th. So it should be 25 hundredths times 10 to the 4th. Again, you have to look at this and ask yourself, is that number written in scientific notation? By checking that, you're checking to see if the decimal is between 1 and 10. 25 hundredths is not between 1 and 10. That's less than 1. So you'd have to be able to move your decimal and your exponent. So if we did that, if we took our number, we wrote it in standard form. If I had 0.25, my decimal is in front, and the exponent tells me I need to move it 4 times. And it's positive, so I'm going to the right. So I'm going once, twice, 3 times, 4 times. So these extra spaces get filled in with zeros. So I'm really looking at the number 2,500. And again, it's a big number, so every 3 from the back, I have a comma. So the comma is between the 2 and the 5. And if I converted that between scientific notation, In order to make this a number between 1 and 10, if I start in the back here and I need to make it between 1 and 10, I move once, that's 250. That's not between 1 and 10. If I move another time, it's 25. It's not between 1 and 10. If I move it another time, I get 2.5. 2.5 is between 1 and 10. So my real answer is 2.5 times 10, and I moved it how many times? Once, twice, 3 times. So it'd be times 10 to the third power. Now again, you could have just looked at this and said, okay, I know my decimal went 1 too far. It's out here in the front. In order for it to be between 1 and 10, it's got to be between the 2 and the 5. So I'd have to go 1 back. And if I'm going 1 back, that 4 then would become a 3, which then makes my answer 2.5 times 10 to the third power.